Hi.
Hello, humans. Happy algebra doing. Happy math. Yay. So, 9-4 algebra notes factoring differences of perfect squares. So, some key vocab to start off. Factoring. When you think of the word factoring, you should be thinking of multiplication. Factors are two things that multiply up. 12 and 2 are factors of 24 because 12 times 2 gives me 24. Differences. When you are asked to find the difference, that is talking about subtraction. Keep that in mind. That's important. Perfect squares. Perfect squares. Examples of perfect squares of numbers are things like 16, 64, 81. Anything that you're multiplying times itself. 9 times 9, 81. 10 times 10, 100. So on and so forth. Variable perfect squares, back from Unit 2 when we talked about that. Any perfect square, any variable that has an even exponent is a perfect square. So x squared is a perfect squared. X to the fourth is a perfect squared. X to the sixth is a perfect squared. X to the eighth, so on and so forth. And that's because x squared is x times x. X to the fourth is x squared times x squared. X to the sixth is x to the third times x to the third. Not odd numbers or odd exponents, because in order to get up to x to the fifth, I would need to multiply by x to the fourth and x, or x to the second and x to the third. And that doesn't work. It's not the same thing, so it's not a perfect square. You get the gist. Up next, we have the definition of conjugates, which we talked about back in 9-1, I think. And a conjugate are just same terms with different signs. And when I say different signs, I mean different signs between them. So, for example, generic, A plus B and A minus B are conjugates because they have the same terms, A and B, A and B. There's just an opposite sign. One is a plus, one is a minus. Doing what we do when we have two binomials that are set equal to each other, doing that double distribution gets us A squared minus AB plus AB minus B squared. What's nice about the conjugates, because they have those opposite signs there, it gets those two middle pieces to cancel. Totally okay if you have those in different directions. BA is the same thing because commutative property. Those cancel out nicely, and I'm just left with A squared minus B squared. So, looking at these two binomials that we're here double distributing, what is the difference between them? Simplify them, compare them. Hopefully, you're recognizing that the difference between them is the fact that this first set here are both positive numbers, whereas the second set over here are conjugates. They have those opposite signs going on between them. And you can see that that changes two main things. That opposite signs get those middle pieces, the 8x and the negative 8x, to cancel out, which is awesome. Makes our lives easy. And that negative also turns that 64 into a negative. 8 times negative 8. But over here, those 8s in the middle, those 8x's aren't going to cancel. They add up to be a 16x. So what we're doing today, because again, double distribution isn't new. We've been working on that for a long time. What we're doing today is you're going to be given something that looks like this, and you're going to need to work backwards to get the two binomials, aka factoring. So, got some fun stuff ahead of us.